Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question binary search tree iterator. In this question we need to implement the BST iterator class that represents an iterator over the in-order traversal of a binary search tree. There are three methods. First is the constructor, in which we need to initialize the BST iterator class. The second method is hasNext, which will return true if there exists a number in the traversal to the right of the pointer, otherwise return false. And lastly, the next function, which moves the pointer to the right and then returns the number at the pointer. It is given that all the next calls will be valid and there will be at least a next number in the in-order traversal when the next is called. In the first example, as we can see, we need to first return 3, then 7, then 9, 15 and 20. That is the in-order traversal. We are given the constraint of the problem. There is also a follow-up question attached with the problem, and we will see that in the later part of the video, so do watch it till the end. The simplest way of doing this problem will be to take all the values in order fashion into a list and then iterate over the list and return whatever that is in the particular index. So we'll first see that approach. So we'll have a list which will hold all the values and the index. We need to put all the values in order fashion into this list. So we will do an in-order traversal on the root. So the data will be ready in the constructor itself. We will have a list of all the values in order fashion, and we just need to return the value present at index. So in the next, as we know, all the next calls will be valid. We just need to return the value present at index and post increment it. In the hasNext, we just need to check if the index is less than the list size. So when we run this code, it gives proper result. Let's submit this. So it got submitted successfully. The time complexity for both the methods is O of 1, but as we are using a list to hold all the values, the space complexity becomes O of n. Now this is not in line with what the question is asking us. As in the follow-up problem, it asks us to implement the next and hasNext to run an average O of 1 time using only O of h memory, where h is the height of the tree. There is a way we can solve this problem without having all the values in the list initially. We can do the partial in-order traversal. Let's see how we can use this technique in order to solve this problem. Suppose this is the tree that we have. Now in this concept we will be using stack. It can be a bit tricky at the very start, but do bear with me. We'll have a stack and we will start pushing all the left values into the stack starting from the root node. So we will start pushing 10, then comes to 5, then 3, then 2. And then the next function is called. When this next function is called, what we need to do is we need to pop the element from the stack and return this element. But before returning this element, what we need to do is, if there exists any right value, we need to call the partial in order on that and do the in ordering again. Now it will be more clear when we reach the node 5. So again the next will be called and 3 will be popped out, and as no right child exists for it, it will be the same as 2. When the next function is called now and 5 is popped out, we need to call the partial in ordering on 6 again. When we call that, as there is only one value, 6 gets inserted into the stack. Now the next is called, so the 6 gets popped out, and when 6 gets popped out, we are done with the left side of the tree. There only remain value 10. So again when next is called and 10 is popped out, we need to call the partial in order on its right subtree. When we call that, the two values that get inserted into the stack are 14 and 12. The same logic is called again and again in the next call, and as we know, all the next call will be valid. So we need not to take care of that the next will be null. In the hasNext, we'll always give the answer till the stack is not empty. Now let's see how we can do this code wise. So we'll start fresh. We won't need any list now. We just need a stack to hold the node values. In the BST, we will start with the partial order. So we'll call that function as partial in order and call that on the root. The declaration of this function, we need to push values into the stack till the node is not null, till we reach the leftmost node. push values into the stack and move the value to the left. Now in the next method, we know that we just need to first take the top value, and before returning the value of this top node, we need to first call the inOrder function on its right subtree first, and then simply return the value of the top node. In the headers, we just need to check if the size of the stack is greater than 0. Stack has a function for that. Let's run this code. So it ran successfully. Let's submit this. So the code got submitted successfully. The average time complexity of both the approaches is O of 1, while the space complexity now becomes O of h. Thanks for watching the video. See you in the next one.